Okay, here's our second video of section 2.1. We've started talking about sets and we've learned the three different ways of representing a set. Remember word description, roster method, and set builder notation. In this video, we're going to add to that discussion and talk a little bit about special notation we use when talking about sets. So we're going to do examples 4, 5, and 6 in this video. The first thing we're going to talk about in this video is what we call an empty set. An empty set is also called a null set. It is the set that contains no elements. The empty set is represented either by squigglies with nothing inside, so an empty set, or a little circle with a slash through it. So a lot of times students use that notation to represent 0, but actually that notation really means nothing, that there is nothing, there's no elements in my set. So we've got to be careful when we use the number 0 versus saying that there's nothing, because 0 is actually a value, it is something, but empty set or a null set means there's nothing there. So you've got to be careful with the correct notation that you mean. So you could use either notation, but do not use both at the same time. So we either use the brackets with nothing in them or the circle with a slash through it, but we don't use both at the same time, okay? A few examples of empty sets are a set of all numbers that are less than 4 and greater than 10. And because they have this one particular word and, there are no numbers that are less than 4 and greater than 10 at the same time. Now, if that word was something different, then it might not be an empty set. But in this particular case, there is no number that is less than 4 and greater than 10 at the same time. So we would say that that was an empty set. Look at the next one. This one's given to us in roster method. It says the set of x's such that x is a dog that speaks. I know some of you have seen those YouTube videos where the dog says, "I love you," and it sounds like he's talking, but really there are no dogs that speak. So that would be another example of an empty set. I want you to look at example number 4, A, B, C, and D. I want you to pause the video and I want you to tell me if you think each of these sets is an empty set or not. Looking at example number 4A, it gives us a set with an element in it. It gives us the number 0 inside. So there's actually one element in my set, so it's not empty. That is not an example of an empty set. Did you say that B was an empty set? That's kind of a trick question. B is not an empty set because it's not even a set. Remember that in order for it to be a set, it needs to be written with the little squiggly brackets. Right now, this is just a floating number. So technically, we can't say that this is an empty set because it's not even a set to begin with. So be careful with that one. That's just notation trying to trick us. If you look at C, it says C is the set of all x's such that x is a number less than 3 or greater than 5. Now this is a little bit different than the word and. This one has the word or. Can't I be a number that's less than 3 or a number that's greater than 5? So what's a number less than 3? Couldn't I say 2, 1, 0, negatives? Or could I be a number greater than 5, 6, 7, 8, 9, and so on? And so this would not be an empty set. Because of that word or, this is not an empty set. Remember, if it was the word and, it would be empty. So you've got to be very careful with the words that they use. The last one says the set of all x's such that x is a square with 3 sides. Well, hopefully we all know that a square has 4 sides. And so this would be an empty set. There is no such thing as a square with 3 sides. We could use the notation, the squigglies with nothing inside, or remember we can use the notation with the circle, the slash. Remember, we don't use both, so you could choose one or the other. This would be, out of all 4, would be an example of an empty set. Okay? The next notation we're going to talk about is this little notation that looks like kind of a smoothed out E, or an E with a slash through it. What that symbol means is it's used to indicate that an object is an element of the set. So it replaces the words is an element of. So I can say, I don't know if I have A is an element in this set because A is inside there. A is an element of that set. Or I can put a little slash through it and say something like this. C is not an element of the set because C doesn't belong in that set anywhere. Okay, so that little kind of smoothed out E is a notation that we use to represent is an element of. I want you to look at example number 5 and tell me if you think each statement is true or false, looking very carefully at the notation. So pause the video for a second, look through these three, and see if you think it's true or false, and maybe why it is or is not true or false. When I look at example number 5A, it says that R is an element of this set, A, B, C, all the way through to Z. So it looks like it's the alphabet. Well, is R inside that set somewhere? Sure, so I would say that that statement is true. R is an element in the alphabet, in that set. Letter B says 7 is not an element of this set. And this set has the elements 1, 2, 3, 4, and 5 and stops. Do you see how it doesn't have the 3 little dots, so it doesn't keep going? So the only elements that are in my set are 1, 2, 3, 4, and 5. So this statement is a true statement because 7 is not an element of my set. All right, look carefully at C. C says technically that set A is an element of this set. This is another kind of trick or tricky question. This statement is actually a false statement. I know, most of you said true, right? Well, you've got to be really careful. If it said A is an element of this set without the little squigglies on your A, then that would be true. A is inside, but the set A is not inside. What I mean by that is that it would have to have squiggly brackets inside my set in order for the set A to be inside the set. And so that's a really tricky question where one little piece of notation makes a huge difference. So again, if it just had the A, I could say that A is an element of the set. Or if inside my set had brackets, then I could say that the set A was in the set because the whole set is inside. But if it just was given to us like the problem, that is not a true statement. That is a false statement because of the extra brackets that they have on that A. Kind of tricky. You might want to write that one down, highlight that, and study that to make sure that you don't get tricked. Okay? The last little thing we're going to talk about in this video is what we call natural numbers. We use the symbol capital N to represent natural numbers. And a natural number is a number that starts at 1 and goes up, kind of the way we naturally count. 1, 2, 3, 4, 5. Okay? So when I say natural numbers, we need to know that it starts at 1 and goes up from there. So if you look at example 6 with me, it asks us to express each of the following sets using roster method. Ooh, do you remember from the first video what roster method means? Yeah, roster method means you're going to list it out, right? And so using our proper notation, it says here for A, the set A is a set of all natural numbers less than 5. So we're going to use good notation using the capital A. We're going to have an equal to sign. We're going to have our little squiggly brackets. And then we need to list all the natural numbers that are less than 5. Now be careful, what number is less than 5 that is inside the natural number set? I got 1, 2, 3, and 4. Do you notice that I started at 1 because that's what natural numbers start at? I did 2, 3, and I stopped at 4 because I want numbers that are less than 5, not less than or equal to 5. Now, could I have written this as A and then 4, 3, 2, 1? Sure, as long as I have those same 4 elements. Remember, it doesn't matter the order, as long as your elements are correct. So either one of those answers would be acceptable. All right, part B says set B is the set of natural numbers that are greater than or equal to 25. Pause the video and tell me how you would write this in roster method. So I have B equals 25, 26, 27, and then I have a dot, 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 right? Because that tells me that I'm not only greater than or equal to 25, I start at 25 and I go up, I can't possibly list all the numbers after that. And so we use those 3 dots to represent that that pattern is going to continue. What I would like you to do is I would like you to write 3 different numbers before we do that dot, 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 so I can see what pattern you're following, okay? So in this case, it would be 25, 26, 27, dot, 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 so I know you're going to continue going up. For part C, it says that E is the set of all x's such that x, remember this notation? X is an element in the natural numbers, and x is even. So can you write me the roster method for the set of all x's if x is a natural number and x is even? I wrote it like this. I said E is the set that contains the numbers 2, 4, 6, and then I did ... to represent that I was going to continue with that pattern. I'm a natural number, so I'm 1 or bigger, and I'm even, 2, 4, 6, 8, 10, and so on. So there's an example of that set in roster method. So make sure you're careful with all the different notation they're going to use. Make sure that you understand what it means and that you could apply it with all the different set examples that we have. Let me know if you need anything.